We've seen that the electrons in an atom can be modelled by electron shells, like carbon-6 electrons in the arrangement 2,4, or chlorine-17 electrons in the arrangement 2,8,7, or potassium's 19 electrons in the arrangement 2,8,8,1. But it's the outermost valence electrons that determine an atom's chemical behaviour. Potassium has 1 valence electron in the fourth shell, chlorine has 7 valence electrons in the third shell, and carbon has 4 valence electrons in the second shell. It's these outermost electrons that are involved in the bonding with other atoms. Sometimes valence electrons are shared between atoms, resulting in molecules and covalent compounds. Other times, valence electrons are transferred between atoms, resulting in ions and ionic compounds. It all comes down to the number of valence electrons in the atoms involved. The periodic table organizes elements with the same number of valence electrons into groups. Group 1 elements have 1 valence electron, and that's why lithium, sodium, and potassium have similar chemical properties. Group 2 elements have 2 valence electrons, and that's why beryllium, magnesium, and calcium have similar chemical properties. If we jump over to group 13, we find elements with 3 valence electrons. Group 14 elements have 4. Group 15 have 5. Group 16 elements have 6. And group 17 elements have 7 valence electrons. And that's why fluorine, chlorine, and bromine have similar chemical properties. Group 18 elements have a full outermost shell. With the exception of helium, they have 8 valence electrons. This full valence shell makes these group 18 elements unreactive, like helium, neon, and argon. We often reduce a shell diagram to show just the valence electrons as dots around the element's symbol. These are called Lewis dot diagrams. So chlorine's 7 valence electrons are shown like this. And nitrogen's 5 valence electrons are drawn like this. So we've seen that it's the number of valence electrons that determine the chemical properties of elements, and that elements with the same number of valence electrons are in the same groups of the periodic table.